Shri Sathya Sai. Dear learners, welcome to Shri Sathya Sai Loka Seva Gurukulam online classes. We are doing mathematics, permutations and combinations. This is the 12th part, which is the last part of this particular chapter. In this chapter, we have done a lot of questions on permutations separately, followed by combinations, and the terminal exercise which we are going to do today, that was started in the last part, which had questions on permutations and combinations combined. There are very few formulae in this particular chapter. If we are talking of only arrangement of objects, then we use the formula for permutation, that is NPR. There are total n objects and r objects are taken at a time, and if we have to arrange them in a particular fashion, the formula that we use is factorial n divided by factorial n minus r. Coming to combinations, we represent it as NCR. That means out of total of n objects, we are choosing r objects at a time. Then our formula becomes factorial n divided by factorial r, and in the denominator itself we will be taking n minus r. So in the last part, we restricted ourselves to these two formulae. Let us continue with the questions given in the exercise. Question number 13 is: a contractor needs 4 carpenters. 5 equally qualified carpenters apply for the job. In how many ways can the contractor make the selection? Just try to read the question and understand it properly. How many contractors are there in all? Contractor is only one. Now that particular contractor has to choose 4 carpenters out of 5 equally qualified carpenters. So total number which is available for the contractor to choose is 5. Now out of those 5, he has to only choose 4. So if you look at it, it is very, very simple question. So required number of ways will be 5C4. It is choosing 4 out of given 5 people. Now solve it. What is 5C4? It is factorial 5 divided by factorial 4, and this will be factorial 5 minus 4. Solve it and see what answer do you get. This will become 5 into factorial 4, and here we write down factorial 4 only, and this will be factorial 1. So the answer here is 5 ways. This was a very simple application of combination. Now let us look at the next question. In how many ways can a committee of 9 be selected from a group of 13? Committee of 9 has to be selected from a group of 13. So required number of ways: out of 13 people, how many have to be chosen? 9. Now solve factorial 13. Let's first, before going on to factorial, let's just write it. 13C9. How will it be written? It will be written as factorial 13 divided by factorial 9, and in the denominator only we will be having 13 minus 9. So this will become factorial 13 divided by factorial 9. And what is 13 minus 9? 13 minus 9 is 4. So dear learners, please solve it and see what answer do you get. By now, it would be very easy for you. It should be very easy for you to solve the factorial. So it is 13 into 12 into 11 into 10, and this I can write down factorial 9. Here factorial 9 only, and factorial 4 can be written as 4 into 3 into 2 into 1. So solve it. Just see what is getting cancelled. Factorial 9 is getting cancelled. 4 3s are 12. It is getting cancelled with 12. Now we have 2 out here. So 2 5s are 10. Now multiply 13 by 11, and the product has to be further multiplied with 5. So we get the answer 715 ways. So in how many ways can a committee of 9 be selected from a group of 13? 715 ways. Moving on to question number 15. In how many ways can a committee of 3 men and 2 women be selected from a group of 15 men and 12 women? We'll proceed in the same way as we did in the last question. Read the question again. You see, a committee of 3 men and 2 women has to be selected out of a group of 15 men and 12 women. So from 15 men, how many men have to be selected? 3. And from 12 women, how many have to be selected? 2. So out of 15 men, we choose 3. So it will be 15C3. And out of 12 women, we choose 2 women. So it would be 12C2. Now solve it. 15C3 multiplied by 12C2. So this is factorial 15 divided by factorial 3. And what is 15 minus 3? 15 minus 3 is 12. And here we will be having factorial 12 upon factorial 2. And what is 12 minus 2? 10. Now simplify it and see what answer do you get. You can cancel factorial 12 on both sides also. Whatever is the easier method for you, adopt that. So when we solve it, we will be getting 455 here, and here we will be getting 66. Multiply these two numbers and you will be getting the answer 30,030. So the number of ways in which we can select a committee of 3 men and 2 women from a group of 15 men and 12 women is 30,030. We move to the next question. Question number 16. In how many ways can 6 persons be selected from 4 grade 1 and 7 grade 2 officers so as to include at least 2 officers from each category. My suggestion, reread the question, at least understand what is asked here. So 6 persons have to be selected out of 4 grade 1 officers and 7 grade 2 officers. But there is a condition out here. In the selection that we make, that should have at least 2 officers from each category. So at least 2 officers from grade 1 should be there, and at least 2 officers from grade 2 should be there. So let's see how to proceed. In this question, let's first see, out of 4 grade 1 officers, suppose we take 2, because they said that at least 2 officers from each category should be there. So from the first category, we have ensured that 2 officers are chosen. Now, the second category has got 7 officers. Out of those 7, how many should be chosen here? We have chosen 2 from first one. How many can be chosen from the second one? Refer to first line of the question. Total persons to be selected is 6. So 2 we have already selected. So how many more do we have to select? We have to select 4 more. So here you see 2 we have selected from grade 1 officers and 4 we have selected from grade 2 officers. So total number of people who have been selected, 2 plus 4 is 6. So 4C2 multiplied by 7C4. So we have made sure that at least 2 officers from each category are there. In this particular thing, if you see, 2 officers from grade 1 are there and 4 officers from grade 2 are there. Now let's increase this. From grade 1 officers, let's choose 3. We had to choose minimum of 2 from each category, so we can choose 3 also. And out of those 7 officers, now how many do we have to choose? Total is 6. 3 we have already chosen. So how many more need to be selected? 3. 3 plus 3 is 6. Total will be then 6. Then let's move on to the next condition. From grade 1 officers, out of 4 grade 1 officers, we choose all 4. If we choose all 4 from here, then how many can we take from grade 2 officers? We can only take 2 because 4 have been chosen from the first category. Total that number that we have to choose is 6. So 4 we have already chosen. How many more can we select? We can only select 2 more. So in these 3 cases, if you see, the condition that 2 officers from each category should be there, that is being fulfilled. Now you have to just solve the given combinations which we have formed. Just solve it yourself. Factorial 4 divided by factorial 2, and 4 minus 2 is 2. Same way factorial 7, factorial 4 will come here, and 7 minus 4 is 3. Factorial 4 here, factorial 3 here, and 4 minus 3 is 1. Factorial 7 here, factorial 3 will come here, and 7 minus 3 is 4. Factorial 4 divided by factorial 4, and 4 minus 4 is 0. And do you remember what is the value of factorial 0? Value of factorial 0 is 1. Here we will have factorial 7 upon factorial 2. And what is 7 minus 2? 7 minus 2 is 5. You need to solve it and see If we solve this, we will get 210. Here we are going to get 140. And here we will be getting 21. Add these three, we get 371. I hope the question is clear to all. If you see, the solution is very easy once you have understood the question. Moving on to question number 17. Out of 6 boys and 4 girls, a committee of 5 has to be formed. In how many ways can this be done if we take 2 girls, exactly 2 girls, and B part is at least 2 girls? So let's see. First part. Now, after solving the last question, you would be finding it easier. I'm sure that all of you can do it yourself also. So please try it. If you look at the first part, it clearly says that only 2 girls need to be taken. So if we have to take only 2 girls, so what was the total number of girls available? 4 girls. Out of 4 girls, 2 have been chosen. And we have got 6 boys. How many can be taken? Committees should comprise of 5 people. So 2 are girls. How many more do we need? We just need 3 more. So 4C2, out of 4 girls, 2 have been selected. And 6C3, out of 6 boys, 3 have been selected. So we have selected 2 girls and 3 boys. So total number of committee members is 5. Solve this and see what answer do you get. 4C2. So 4C2 will be written as factorial 4 divided by factorial 2, and in the denominator only you will have another factorial 2, which comes by subtracting 2 from 4. And value of 4C2 will come 6. Now 6C3 will be equal to factorial 6 divided by factorial 3, and 6 minus 3 factorial will also come in the denominator. So 6C3 value is 20. So required number of ways 120. Now B part of this question is same as question number 16th. Here you see at least 2 girls. So we will first take 2 girls. Let's take it out of 4. 2 have been taken. Out of 6 boys, then we will be taking 3, because committee members should be 5 in number. Second option could be out of 4 girls, we take 3 girls. And if we take 3 girls, then how many boys do we have to take? Total is 5. So 3 girls we have taken. How many boys have to be chosen? Only 2 boys have to be chosen. 3 girls have already been selected. So 2 more are required. So out of 6 boys we can take 2. Another option is there that all 4 girls are selected. If all 4 girls are selected, then how many boys do we need? Just remind yourself. Total number of committee members should be 5. So we have chosen 4 girls. So how many boys do we need? We just need 1 boy to form a committee of 5. 4 girls plus 1 boy will make 5 committee members. And 1 boy has been chosen out of the 6 boys which were given to us. Now solve this. This will come out to be, this is 120. This one is 60, and this one is 6. Add them. So this answer that we are going to get is 186. We move on to question number 18. In question number 18, it's given that the English alphabet has 5 vowels and 21 consonants. We all know that English alphabet has 26 English alphabets, 26 letters are there. Now out of those 26 letters, 5 are vowels and 21 are consonants. So they are saying what is the maximum number of words that can be formed from the alphabet with 2 different vowels and 2 different consonants. So how many vowels do we have to take? Just 2 vowels. Out of how many vowels? Out of 5 vowels, we just have to choose 2 vowels. So 5C2, we have chosen 2 vowels out of 5. Out of 21 consonants, how many consonants do we have to choose? Just 2 consonants have to be chosen. So we have chosen 2 vowels out of 5. We have chosen 2 consonants out of 21. So 4 alphabets have been chosen. Now they are asking, what is the maximum number of words that can be formed? Now 4 we have chosen. Now after choosing 4, these 4 letters can be arranged in factorial 4 ways. For example, if I have only say 2 alphabets chosen, A and T, so it can be written as AT, it can also be written as TA. Here we do not have to worry whether the word is making sense or not. All they have asked us is what is the maximum number of words that can be formed. So first we have to apply combination formula. After getting or applying the formula for combination, then we have to use the formula for permutation. Factorial 4 will be written for giving us the number of arrangements for the chosen 4 alphabets. Now let's see what answer do we get. So we have to solve 5C2. If we solve 5C2, try it yourself. 5 minus 2 is 3 here. And here we will be writing factorial 21. And factorial 2 will come here, and 21 minus 2 is 19. And factorial 4 will come here. Please solve it yourself. If you see here, you will get 10. This one will come 210. And factorial 4 is 4 into 3 into 2 into 1, which comes as 24. When you multiply it, you will get 50,400. So how many words will we get? We will get 50,400 words. Now question number 19, which is similar to the last question. From 5 consonants and 5 vowels, how many words can be formed using 3 consonants and 2 vowels? It's exactly like the last question. So what is the required number of ways? Out of 5 consonants, how many do you have to choose? We have to choose 3. Out of 5 vowels, how many vowels do we have to choose? Just 2 vowels. So we have chosen 3 consonants and 2 vowels. So we have got 5 alphabets with us. Now these 5 alphabets can be arranged in factorial 5 ways. Simplify it. Here we will get 10. 5C2 is also 10, and factorial 5 is 5 into 4 into 3 into 2 into 1, which comes out to be 120. So if you see, our answer is 12,000 ways. Now let's look at the last question. First, let's read the question and understand it. In a school annual day function, a variety program was organized. It was planned that there would be 3 short plays, 6 recitals, and 4 dance programs. However, the chief guest invited for the function took much longer time than expected to finish his speech. To finish in time, it was decided that only 2 short plays, 4 recitals, and 3 dance programs would be performed. How many choices were available to them? And then there are 3 separate conditions along with that. So question should be clear to you. You see a function and school annual function was there, and as per the plan there were 3 short plays, 6 recitals, and 4 dance programs. But because of the long speech of the chief guest, and then the school authorities, they wanted to finish the function in time, so they decided that we'll cut short the program. That means out of 3 short plays, only 2 short plays will be performed. Out of 6 recitals, only 4 recitals will be performed there. And out of 4 dance programs, only 3 dance programs will be performed. So now we have to see how many choices were available to them. If the programs can be performed in any order. Let's see this A part of the question. This you will write yourself, required number of ways. As I said, out of 3 short plays, how many were chosen? Just 2 were chosen. Out of 6 recitals, 4 recitals were chosen. So it will be written as 6C4. Out of 4 dance programs, 3 dance programs were chosen. I'll again repeat what have we done. We have first choosing it. We are using the formula for combination. Out of 3 short plays, 2 are chosen. So 3C2. Out of 6 recitals, 4 recitals are chosen. So 4C4. Then out of 4 dance programs, 3 dance programs are chosen. So 4C3. Now here it is given that the programs can be performed in any order. Any program can be taken first. So sequence does not matter. So first let us see how many total number of programs are they now performing. So they are performing 2 short plays, 4 recitals, and 3 dance programs. So 2 plus 4 plus 3 is 9. So these 9 programs, they can be performed in any order. So we will have to use permutation also here. So we will write down factorial 9. Now please solve it. That gives the answer to the first part of this question. 3C2 will be written as 3. 6C4, it will come out as 15. 4C3 will be 4. And factorial 9, if you solve it, it will come, let me just write it here, it will come 3,62,880. So dear learners, multiply it and see what is your answer coming. It's a huge answer. 65318,400. 6 crores 53 lakh 18,400. Now in B part, they have clearly written that these items, these 9 items which are chosen, the programs of same kind were performed at a stretch. That means 2 short plays, they have to be performed together, one after the other. 4 recitals, they have to be performed together. And 3 dance programs have to be performed together. Though the sequence of short plays, recital and dance program can change. That means dance program can be 3 dance programs can be performed first, followed by recitals, followed by short plays. So let's see how do we go ahead in this question. We'll start with our usual way, required number of ways. This part remains same. Out of 3 short plays, 2 have been chosen. Out of 6 recitals, 4 have been chosen. Out of 4 dance performances, 3 have been chosen. But they have given the condition that same kind of programs have to be performed at a stretch. So how many types of programs are there? Just 3. Short play, recital, dance. Only 3 are there. So for permutation, we will be just writing factorial 3. Now solve it. This was 3. This has come 15. This is 4. And what is factorial 3? It is 6. So if you multiply it, you will get 1080. Let's look at the last part of this question. It says if the programs of the same kind were performed at a stretch and considering the order of performances of the programs of the same kind. Now this question is different from the earlier part. Here you see programs of same kind were performed at a stretch, which was in part B also. But additional condition is the order of performance of the programs of same kind. Now here when we are talking of, here you see 3 programs, 3 short plays. Out of these 3 short plays, 2 have to be their order of performance of the program of the same kind. We have to consider that. So instead of writing 3C2, now this arrangement is very, very important. So keeping that in mind, the required number of ways here will be 3P2. See, they have very clearly written out here performance of programs. That means the order of the performance of the programs of the same kind. We have to keep that in mind. How many choices were available if the programs of same kind were performed at a stretch and considering the order of performance of the programs of the same kind. So this becomes a question of permutation. It will be 3P2, 6P4, 4P3 and factorial 3 will also come because programs of same kind can be performed at a stretch. Now solve it and see what is your answer. This will be factorial 3 divided by factorial 3 minus 2 is 1. This is factorial 6 divided by factorial 6 minus 4 is 2. This is factorial 4 and 4 minus 3 is 1 and last one is factorial 3. When we solve it, if you see, it is 6 here. Here we get 360. And here we will get 24, and factorial 3 is 6. So when we multiply them, we will be getting 3,11,040. So dear learners, with this we have come to the end of this chapter, permutations and combinations. If you had noticed, the questions are very easy, but they require lot of practice. So please practice as many questions as possible. That's all from my side. Thank you so much. Om Shri Sai Ram.